The directions say to draw an array with 2 rows where each row has 8 counters. So let's go ahead. We'll draw our 2 rows, and I use X's to indicate the counters, and we want each one to have 8 counters. So remember to count this as 1, now 2, 3, 4, 5, 6, 7, 8. And we'll do this again. Make sure you're drawing this on your paper so that you have a 2 by 8 array. Great. Now, if I wanted to count the total number, how many counters are in this array, you could count them, right? 1, 2, 3, 4. You could count them up, and you might be already saying, I know it is 16. 16 what? 16 counters. We always include our units. The next question says, what multiplication equations could be used to describe the array? Well, it had 2 rows with 8 in each row, so I might say 2 times 8. Now, if I just wrote 2 times 8, I don't have an equation. Whenever you hear that word equation, you hear equal in it, it must have an equal sign. So I could say 2 times 8 equals 16, or I could say 8 times 2. Does that also equal 16? Yes. It's like flipping our array sideways. 8 by 2. Same product, just a different order of our factors. The next question asks, can you think of another array that would have the same total number of counters? So we want to have 16 total counters, but it can't be a 2 by 8 or an 8 by 2. We already did that. So pause the video, and I want you to see what arrays you come up with. Play the video again when you're ready to see the answers. Welcome back. You might have said that you could have a 1 by 16 array, which is true. I could have 1 row with 16 in each row. I lost count of how many I'm at. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I could have that. 1 by 16, 16 by 1, the same thing, right? But a kind of, let's call it a more interesting array you might have come up with would be 4 rows with 4 in each row. Did you think of that one? Maybe you already have this drawn on your paper. If not, draw it now. A 4 by 4 array. This one's 4 by 4. Now, take a look at the array that I just drew. What do you notice about its shape? Giving you a hint. It forms a square, right? With 4 length and 4 width. So numbers like 16 have a special name. Those are called square numbers. It means numbers that can be represented by a square array are called square numbers. Square numbers are products of a factor times itself. In this case, our factor was 4. So we did 4 times itself, 4. And the product, which means the answer to our multiplication problem, was 16, which makes 16 a square number. Here's another visual for you. This is repeating what we just said. It's just the way it's phrased in your math journal. A square array is a special type of rectangular array that has the same number of rows and columns. I'm just going to go back for a second. If I looked at the 2 by 8, that would have been rectangular, right? A rectangle in shape. You can see that now if you didn't before. So a special type of rectangular array is a square. Square arrays represent a whole number called a square number. So this drawing shows the first 4 square numbers and their arrays. So if you have a 1 by 1 array, well, that's kind of boring. 1 times 1 is just 1. But not too boring. 1 is still a square number. Proud of it. 1 is the first square number. Now we have what multiplication problem? What factors? 2 times 2 to get 4. In our next one, we have a 3 by 3 array to get 9. And in our final, we have the one we talked about, a 4 by 4 array to get 16. Now, I want you, this is from your math journal. So I should have told you to open up to the math journal page. Let me just peek what page I want you to be on. Page 35. Oops, went back too far. So on page 35 in your math journal, I want you to go pause the video and go fill in the multiplication problems we just wrote above our array so that you have those in your journal. And then play the video when you're ready to go on. Okay, hopefully you're on page 35 and problem 1 asks us, draw square arrays to represent the next 2 square numbers after 16. Write each square number. So we have to look at where we left off, right? We just did a 4 by 4 array, so we know that the next factor we want to use is 5. We're going to make a 5 by 5 array. So you can choose to draw this anywhere on your sheet where you have enough space. Oops, I'm doing my rows first, but I know I'm going to make 5 total rows with 5 in each row. And double check that you did that you have 5 total rows with 5 in each row. Sometimes people forget to count the first X they drew and then they only have 4 in each row. I have 5 by 5. So the product or the square number would be 25. And let's label this one that this was our 5 by 5. Now I want you to pause the video and go ahead and finish, do letter B and play back the video when you're ready to see the answer. Ta-da! So for your final array, you should have had a 6 by 6 array, which gives us a square number of 36. Now, something fun to do with square numbers is to notice patterns. All the time, mathematicians are asking you to notice patterns. And when in your journal or in your HomeLink or on a test or in your mathematical life, you are asked to notice patterns, it's helpful to use math vocabulary. So some of the vocab you already have, we have all our place value vocab from last unit, you might consider that. But 2 very common words are even and odd numbers. And those are actually math vocabulary, right? So maybe a pattern I'm noticing about my square numbers, if I wanted to use even and odd, let's see, 1, 4, 9, 16, 25, 36. I notice it goes odd, then even, right, E, odd, then even, then odd, then even, then odd, then even. There's a pattern for you using great math vocabulary. I could explain that each square number alternates between being an odd and even number. Okay. I also, if I wanted to notice a pattern in the factors, first I used 1, then I used 2, then I used 3. Well, that's a pretty basic pattern, right? You're noticing that the factors each time go up by 1, increase by 1. Very basic pattern, but a pattern nonetheless. So when you're asked for patterns, don't panic. You have all the tools you need because you are amazing mathematicians with amazing mathematical vocabulary. Just think through, what are you noticing? And how could you phrase it trying to use some of this math vocabulary too? Good luck, mathematicians.